Alrighty. So tomorrow, Wednesday, 1 p.m. will be your programming test. So please make sure 1 p.m. is not like 1:30, well, like a written test. It's a different test, programming test, back to normal. If you got any questions or concern about written test 1, there's no deadline. You can talk to me anytime during the semester. During office hour, if you want to approach me briefly after class, I'm more than happy to stay a little bit longer. Okay, anyway, written test, we can talk about it later. And programming test 2 will be tomorrow. And you have been released the guide, the practice test, and also the lab 3 solution. I also released last night, also the, sorry, not last night. Was it last night or this morning? Okay, either way, maybe this morning. So also the recording for the last Saturday session of the recording of the review, and also some iPad notes. So you can take a look if you want to go over the solution with the TA. I think she did a pretty good job in the session. Okay. And my last minute tip for you guys, if you want to do what might be the best preparation for you before tomorrow, I would suggest try to redo the practice test 2 if you can, and then just make sure you really set a timer for yourself to see exactly where you might get stuck for the practice test 2. All right, that's very important. Okay. And something very important, and then we'll move on to the new lecture. Okay. So I might skip the recap part just for today because I really want to start you guys fresh about inheritance. But I want to mention some very important exercise for you moving on. So you will see that under the object equality lecture around this area here, of course, you will see the programming test 2 review session. Okay, that's something might be so relevant to you, maybe for tomorrow. Make use of it. And there's also another one here called tracing exercise. So that one there, I got 2 things for you. So if you take a look at the document there, it's more like a clean pages. I would suggest maybe you can download to your maybe tablet computer. You can print it out and then try to do this tracing exercise over here. Just convince yourself why each assertion over here, assert equals, assert saying, why do they pass? Also read through the comments very carefully. I think this one here is going to help you, maybe not for tomorrow's test, but definitely for the coming written test and also the exam specifically. Okay, that's very worth your time doing. So there are 2 sets over here for the exercise. The first one, they should more like a warm-up, just basic J units using point V1 and point V2. The second set there is about person and person collector, just showing you how to implement the equals method and also how you can test it. Okay. And if you want to go over any solution with me, you're also welcome to. I also got some solution walkthrough video right here. It's about 1 hour long, but feel free to skip any parts or maybe fast forward, whichever trick you may want to do to save your time. Okay? But anyway, the resources are there, so make use of it. So guys, any questions about the course before we move on? All good? Okay. So I would like to start ourselves fresh about the inheritance, the topic. Arguably, this is the most important topic for the course. Since the course is about advanced OOP, you cannot claim yourself knowing about advanced OOP until you know the whole story about inheritance. So that's why I take this part very seriously. Of course, I'll try to teach the best I can from my part. Of course, you guys will have to make sure you do lab number 4, which I'm going to release pretty soon, maybe after your test tomorrow. So you can maybe steadily start slowly for lab number 4. And then also there will be quite a bit of justification and mental understanding you want to build along the way. It's quite a challenging topic, I would say, if you're learning that for the first time. But don't worry, I'll guide you through. I got all the resources there for you, but I'm going to go slowly. So I'll plan to do the inheritance lecture for about 6 to 6.5-ish lectures for the semester. After that, we got about maybe 3.5-ish lectures left. In that case, I would like to talk about recursion very briefly. I'll talk about just what you need for this course and also for the exam. I'll give you also lots of resources to practice before the exam. If you study those resources for recursion, you'll be just fine for the exam. But the most important thing is to really learn recursion well. So when you move on to next semester about 2101, it's going to build a very solid foundation for you. So I just want to put you in perspective. All right, let's now talk about inheritance. So there is one exercise I sent to you guys maybe on Sunday. Okay, that one's more about design exercise. So if you click on that one there, it's just about some problem here. We're going to use that as a running example for all the inheritance lecture. This is another one, which I'm going to introduce a little bit later, about smartphone. But this one here is more like a simple one, like a student management system. So I would say even though I already start talking about it today, you may still want to spend some time doing this design exercise for you. It's also going to give you some more insights about the OOP, right? I'll encourage you to really try this out. It's going to also worth your time. All right, let me now go directly to inheritance. Let's do a little bit like a learning outcome walkthrough, and then we'll dive into the example, okay? Step by step. All right. All right, so we're going to learn about, first of all, before we learn about inheritance, let's learn about what if we don't have inheritance. What's going to be the consequence? That's the first thing, mainly today. All right. So we're going to go over the student management system problem and see how we can solve it by not using inheritance. I'm going to give you two alternative solutions that are rather intuitive and also common. They both work. Don't get me wrong. Both of them work programmatically. But I'm going to criticize them on from the design point of view to say your software project is going to last for long term. So we want to make sure your project is going to survive through all the important design criteria. So talk about it today. And then we're going to introduce some keywords for implementing Java classes inheritance, namely the super keyword and also extends keyword. And also later, we'll show you how you can do typecasting, which we kind of briefly talk about in the equality lecture anyway, but we can talk about it. So this part here most likely will be on Thursday, okay, after your test. And then we're going to revisit the ideas about static type, expectation, and also dynamic type. So this time we go a little bit more general, and then I will intuitively introduce to you two concepts. One is called polymorphism. All right, so don't worry too much about exactly what that means. We'll get there. We definitely need to pave some foundation before you can see exactly what that means. But polymorphism is definitely the essence about inheritance. So once we learn about polymorphism, the principle, we're going to apply that in three scenarios, namely how you do variable assignment. When you say x equals y, they should be subject to certain rules if you have some inheritance hierarchy in the context. And also we talk about method argument, call by value. We're going to combine inheritance with call by value together in a way. That's kind of intuitive, but we'll get there, a little bit later part. And then we're going to talk about when you have an accessor, when you got return type that's not void, how do you incorporate inheritance as well? So these are the three important scenarios we have to study. And dynamic binding usually go together with polymorphism. Dynamic binding is more about at the runtime if you got multiple versions of the methods. In our case before, it's about equals method. In general, it can be any method, depending on how you define your inheritance hierarchy. You'll also see that quite a bit in lab number 4, and also the later practice test number 3 I'm going to give to you at some point. All right, so this is more or less the roadmap we're going to follow, right? So I'm going to keep repeating certain principle, but I think this week is more about building the foundation. But next week is going to be the main part, okay? All right, typecasting as well. So there's another kind of exception you guys will have to get used to. It's called class cast exception. All right, whenever you want to do some typecasting, it should be subject to certain rules. If you don't satisfy the rule, you might have something called class cast exception. But we also need to talk about it systematically. All right. All right, let's now start with the very basic, right? Let's now, first of all, let's get used to the concept of the running example we're going to use throughout the inheritance lecture. So guys, please spend just about 2 minutes-ish, more or less 2 minutes. I want you to, if you haven't, read through this passage over here. Okay? I just want you to familiarize yourself about all the terms in this example here and think to yourself, if you were to implement this, assuming that you don't know inheritance, how many classes would you create? How would you roughly implement the methods? Okay, think about it. At this point, this problem here shouldn't be too difficult, right? Think about it. Just about 2 minutes, okay? And then we'll talk about it. Okay, 1 minute. To the least extent, just get yourself familiar with all the terminology, like calculating tuition, resident students, non-resident students, things like that, right? Just get yourself familiar so you wouldn't get lost when I start talking about different designs. Okay, one moment, and then we're gonna discuss it together. So in the interest of time, I wouldn't call anybody out, don't worry. I just want you to think about it, silently, that's okay. But I'm gonna give you some common solution that your previous fellow student have come up with. I'm gonna summarize them to you, and we can study them together. Case study. Alrighty, okay, assuming that everybody somehow just get used to the terms, okay, that's all I need from you. Let's now go over this passage very carefully together, all right? So, well, the first term over here about student management system. There's got to be a class called student management system, obviously. And then that one there is going to store data about students. So you can think about students might be a collection, maybe an array of students, all right? What exactly will be the array element type? Should it be students? But the student include both resident students and non-resident students. That's the question we're asking, right? Right, you can see there's a very important key phrases here. There are two kinds of university students, especially the kinds over here. Whenever you're assigned a task to implement Java classes in OOP, whenever you see any kind of like a keywords like hierarchy, kinds, or maybe any taxonomy of certain concept. In that way, that means you have to somehow use inheritance ultimately as the best design choice. But for now, let's not worry about inheritance just yet, assuming that we don't know anything about inheritance. So there are two kinds of students. So the first kind is called resident students, okay, resident students. And the second kind is called non-resident students, all right? These two kinds of students, they share something in common. They also have some unique characteristic. Let's talk about them separately. What do they share in common? So both kind of students, they actually have, let's highlight them. So they actually have name. They also have their registered courses, right? So these two are the obvious attributes you can easily declare like before, right? So just array of courses, and you can also assume we have a course class. That one may not be so important in this example discussion, but it could be there. And also both students are restricted to register. So there should be a register method as well, just to add the course into the array, right? That's also obvious about how to implement it. And we might have some certain constraint about how many courses or like how large the array should be initially. Okay? That's something we know how to do. And the next one is interesting. Okay? The next one here is about calculating the tuition of a student. All right? So when we say calculating the tuition, you can think about the tuition itself can be split into two parts. The first part is just about base amount. Let's say, for example, let's say there are two students here. One is resident students, the other one is non-resident students. Let's say they're classmates. They're registered to two courses together. Let's say each course will cost maybe $500, let's say, right? So base amount will be just the sum of the fees for individual courses. In this case, two courses, $500 each. That'll be $1,000. And now, there will be some discrimination here. Although it's not really nice to hear, but there will be some discrimination we have to handle. For resident students, there is something called premium rates. Okay, I'll highlight it first. For resident student, it is something called premium rates. Let's assume for resident student, they have to live on campus. We're going to charge them a little bit more for accommodation, for meals, etc. Let's say, right? So let's say $1,000 is only the base amount. We have to multiply 1,000 by some premium rate, for example, 1.2. In that way, they have to pay $1,200, right? You got to pay a little bit more. On the other hand, for non-resident students, they have something called discount rate right here. They don't live on campus, so they can be waived about the fee for accommodation and the meals. So let's say we got base amount, which is 1,000. We can multiply by some discount rate. Let's say 0.75, 25% off. So they only got to pay $750, right? So whenever you want to calculate tuition, you have to calculate base amount. The way to calculate the base amount will be just the same between the two kinds of student. But once you calculate the base amount, you have to apply certain student kind specific rates to really calculate the final amount, right? So that's something we also got to pay attention to. All right. And then, of course, you got other things like each course has a fee. That could be some attributes, and also you can set a fee, right, etc. So that's more or less about the key phrases we have to identify. So we definitely will need student management system. We'll need course. And then now the question is, between students resident students and non-resident students, how many classes do we need for these three concepts over here? We got choices. All right, so let's now talk about it. All right, so at least everybody is kind of familiar with the problem, at least. All right, let's now talk about it. Solution number one, without inheritance. Okay, this attempt, this design looks promising because there's only one class. So let's not worry about student management system. Let's not worry about course just yet. Only focus on students. Okay, that's the most important one to resolve. So let's say we only got one class called students. And that one somehow is going to encode resident students and non-resident students. Okay? Just before I talk about it, I forgot to talk about one thing. So the two designs we're going to talk about today, they are not going to use any inheritance. They're going to work, both of them. However, we're going to criticize them using certain design principle. Let me talk about design principle first before I talk about this one. Okay? So let me start a new page. Let's talk about two design principles which we're going to use to evaluate the two designs. Okay, so here we got design principles. Two of them. Okay, the first one is called cohesion. You may have heard about this maybe in the first year. If no, maybe in your English class, maybe your teacher told you that whenever you write an English article or essay, the essay better be cohesive, right? Something like that. So we're using similar concept, okay? What's really cohesion? Let's define cohesion in the context of OOP. So that would mean the attributes and methods in a single class. So whenever you want to evaluate cohesion, you are evaluating class by class. Okay? In a single class, should serve the same purpose. Whatever purpose you define for your application, as long as they're serving the same purpose. Another way to put it is this. You can say it should be under a unifying theme. Should be under a unifying theme. Again, whatever theme it is, you're going to decide. Maybe the theme is about vaccine. Maybe the theme is only about distribution center. Maybe the theme is only about app store. Right? So you got to make sure you define the theme for your class. Okay? So the principle about cohesion is actually not a very new concept. Back in the operating system for Unix, which is in our prison lab, in the Lassam building or in the Williams-Moore Center. For those of you who are taking maybe 2031 or 2032, the C course or Unix course. So the Unix principle actually has cohesion primarily encoded. Okay? So let's make this note here. So we can correspond this to the Unix principle. Okay? So for example, you know about the ls, which is going to list all the directories. You know about cd, which is going to change the directory. Or you know the pwd, for example, which is going to tell you the absolute path for the current directory, right? Things like that. So each command is going to do one thing and do it well. It's not going to try to do two things separately. Each command should do one thing and do it well. It's a very simple but very powerful design principle, right? So that we can apply this, each command is like our class. Each class should only do one thing and do it well, conceptually. If it's trying to do somehow two things that are not exactly relevant to each other, somehow, then we should really say it violates cohesion. We'll see. All right? So the first design principle is about cohesion. Okay. Any questions? Just conceptually. Pretty simple, pretty straightforward, but we're going to apply that to evaluate the two designs we're going to introduce. All right, the second principle is called single choice principle. Single choice principle. It's actually a very general design principle. You might learn a little bit more about it, maybe in 3311 in your software design course later in the third year. But in this course, we are trying to restrict about the scope about how you can actually violate the single choice principle. Okay, let's talk about, remember back in the OOP review lecture, we talked about helper methods, right? The reason that you want to use a helper method is because you want to avoid code duplicates. Whenever you want to repeatedly use a fragment of code, you just define a helper method, just call the method instead of writing the same fragment of code over and over again. So that one there, for our purpose, you will violate the single choice principle if you got duplicates in your code. All right, that will be how you can violate this principle. Okay, let's now try to define the single choice principle more generally. Okay, whenever you want to do a change to the software, in our case, Java classes, should impact a minimum number of places. And when I say places over here, it can be maybe minimum number of methods or minimum number of classes, right? Depends, okay? So here, it could be methods or it can be classes. And when I say minimum here, it's a little bit flexible over here. Of course, if I want to make a single change, I should really go to at least one place. I cannot go to 0 places and make a one change, right? It's not possible. So at least one place. However, minimum here just saying that you are not really trying to make more changes than necessary. So as long as you can kind of justify the number of places I'm trying to make this particular change is minimum. I cannot do any better. That's okay. You're still satisfying the single choice principle. So the minimum here is kind of flexible. Okay, it's not like I say it got to be exactly 1. Okay, so minimum here is not necessarily 1, but no more than necessary. So typically, if you somehow want to claim that your software satisfies the single choice principle, you will have to somehow justify. Right? That's more on the human side. You have to justify, not just something you can automate. Okay? So that one is the single choice principle right here. So we got 2 design principles, cohesion and single choice principle. Okay? So we're going to keep these 2 principles in mind, and then we're going to apply them right away. Okay? Let me now go back to the first design. And we're going to focus on just about students, resident students, and non-resident student concept, only these 3. So the design number 1, we have only a single class to incorporate all these 3 concepts. Okay, let's see. And this design attempt, I want to make a very quick remark. This one is really interesting. Okay, design attempt. This is actually a pattern where we are trying to somehow simulate OO in a language that does not support OO. For example, let's say if somehow you want to somehow simulate about how objects will work in Java, but in C language. C language has no classes, has no method call, has no dynamic type. But somehow you can actually use this kind of pattern here to actually simulate. Not exactly this, you got to do some extension. Okay? So this pattern here is along the line about how to simulate object orientation in a non-OO language. For example, C. Or maybe the procedural part of Python.
Why are complicated things? We have linear rate and discount rate. Why shouldn't be just one variable called rate that accepts the actual discount based on the...
Yeah, you gotta bear with me because I'm trying to present different design, right? And then we'll try to talk about it. Yeah.
Because for me, if you do it another way, you can without inheritance and without having...
You can do whatever you like, for sure. And then, but we're going to focus on the 2 design I'm talking about right here. Okay? Yeah. Thank you. All right. So let's now look at this. Let's say we have a class called students, only one single class. All right, and then we have the attributes. They are all shared by all the students. We got array of courses, assuming that we have a course class, and also we got the counter right here. All right, so these are the two attributes that's shared by all the students. All right, and this attribute here is the most critical one, kind. So here I'm making the type of kind integer. Okay, so the kind here we're making some assumption. So right now we only got two kinds of students. Right here. So right here. So when the kind is equal to 1, so that would mean we are talking about the student now being resident students. Okay, I'll say RS. It's a short form. Or if it is equal to 2, it will be non-resident students. Okay, you might be thinking, in this case, we only got two kinds. Why don't we just use a Boolean attribute here? Maybe true means resident students and false means non-resident student. Yes, for this one, for this case right now, it's okay. But in the long term, we might actually want to extend the range of kinds of students, maybe more than two, in which case Boolean wouldn't be suitable. So that's why I'm just using an integer right here. So if you know that in Java, integer is 32 bits. So in theory, you got 2 to the power 32, possible kinds you can encode. But we don't need that many. It might be overkill, but let's be safe. All right. So we got the kind here. I'm going to show you how you can visualize the student at runtime. And let's talk about the individual characteristic for these two kinds of students. So the first one is we got premium rates right here. And we know before the premium rates is only applicable to resident students. Okay? And then we have the discount rate. And that one there is only applicable to non-resident students. Okay? We got these two. And then somehow we are trying to put two unique characteristics for the distinct kind of students in a single class. That's what we're trying to do. That could be potentially an issue, but we'll see a little bit later. And then we have the integer kind right here. All right? And then whenever you're trying to create a student object, you pass the kind. Let's see some example Java code, just roughly, to get some idea. So what we can do is, let's say we have one single line here. We'd say students, let's say RS, standing for resident students. It would be a new students. And right here, I want it to be a resident students. Okay, so I just put the kind to be just 1. All right. And I have the second one here. That one there has students. NRS, which is a new student objects 2. Right, so here it could be 2 here. So that means it's a non-resident students. Right? And of course, you can imagine that there might be a method that can set a premium rate, set a discount rate. Let's ignore the details for those. Let's try to visualize what's going to happen here. At runtime, let's say for RS, okay? RS stores the address of a students right here, okay? So this is my student objects. You can see for every student object, we got 1, 2, and 3. 3 attributes. We got kind, we got premium rates, we got discount rate. So here, let's now map out the 3 attributes over here. So we got the kind. In this case, it is equal to 1. And also we got premium rates, and also we got discount rate. Since we are now talking about resident students, so that means at some point, the premium rate is going to be set. Okay, let's set some value here. So it could be 1.5, let's say. And then at the same time, it's important to note, discount rate is never applicable for this particular student object because that's meant to be used as a resident student. So discount rate is never ever applicable. So I'm just going to put cross over here. So somehow you can think about the space is there, but never used. Okay. And let's have another instantiation. What about NRS over here? So we got NRS stores another object of type, also students, okay, right here. So that one is students, and also we got 1, 2, and 3. 3 attributes. So let's map them out carefully. So now in this case, we still got the kind. In this case, it's going to be 2 as opposed to 1. And then we have the premium rates. We got discount rate. And now this particular student object here is meant to be used as a non-resident students. That means only discount rate should be applicable. Okay? So at some point, we're going to set it. Why don't we say it's just 0.5? But at the same time, the premium rates for this object here is never applicable. So let's say the space is there, but it's never used. So you can see both instantiations. Whenever you're creating a student object, yes, you can use a kind value to really represent it's either 1 or 2, resident or non-resident. But once you commit to the kind of students, you're going to waste one of the spaces. Right? That doesn't sound like a right idea. Okay? Right? Question so far? All right? So, of course, when you actually want to use it, and then we'll talk about design principle very soon. So let's say I can say RS right here dot get tuition. I can also say NRS right here dot get tuition. So when I call rs.get tuition right here, I'm going to use the premium rates to calculate, on top of the base amount, like what we said earlier. And here, when I say nrs.get tuition, I'm actually referring to this object here, but now I'm going to use a discount rate instead. Right? So conceptually, that's what's going to work. Okay? But let's talk about another 2 methods here. Or get tuition, actually. Let's now dive into it. So for the get tuition, this part here is about a common part that's going to be done for both kinds of students. So this is going to calculate the base amount. And that one there is very, conceivable. You simply just initialize tuition, go over all the courses, and then add them up, right? That one's easy. Base amount. And then, this is the important part. Get tuition, we have to know, depending on get tuition, the context object is either resident students, in which case we have to use the premium rates. If that's NRS, we have to use the discount rate. How do we tell? We have to look at the attribute kind, whether that's 1 or 2. So that's why you see the if then else structure over there. If the kind is equal to 1 versus the kind is equal to 2. You can see when kind is equal to actually 1, in that way we have to apply the premium rates for resident students versus discount rate for non-resident students. Right? We have to do that kind of discrimination in each method basically, because we know we have to handle different kinds of students in this single class. All right? One more. What about for register? So for the register here, you definitely will have to do some common part where you actually have to add a course into the array. But let's say we have some policy here. Let's say for resident students, you can register for up to 6 courses, but for non-resident, only up to 4. Let's say, just different. Okay? In that way, you still actually have to put this if here, if kind is equal to 1, and then do 6. Versus if kind is equal to 2, and then you do 4. Okay? That's a distinction. All right? Make sense so far? All right? So the main insight to this for this design, let me summarize, and then we'll talk about critique of this one, this design here. Number 1 is about the kind. Depending on the value for the attributes, we're going to decide. And then for every method, you will have to make sure that method will act accordingly, according to the kind value at the runtime. All right? So what we want to do now is to criticize about this design here, design number 1. Okay, let's do one by one. Okay, the same design. Okay, what about cohesion? If you want to check to see if the class is violating cohesion, you're basically asking, are we somehow putting things that are not really relevant to each other in the same class? That's the main question. Yeah.
Yeah, because we're using both rates for every single type of student. So, like if you're a
Uh-huh.
resident, you're going to get the
Yeah. Yep, that's exactly right. Thank you. So if you look at the visualization, that's really the main hints. You can see that the same student object here, the same structure, but always you got one of the discount rate or the premium rates not used. Right? So that means they are not somehow always compatible. So you shouldn't really mix these two. Okay? So that's very good. Okay? So you want to say these two are somehow mutually exclusive. They shouldn't be put together. Okay? Mutually exclusive. Should be put in separate classes. You want to make sure every attribute in your method will be totally utilized. You shouldn't really have the kind of students where one attribute will never be used. So that's a design signal that you want to watch out for. All right, that's about cohesion. What about single choice principle? And single choice principle for our concern is only about, are we having duplicates? For example, you can see right here, this calculation here and this calculation here, it's not really duplicate, right? Because we are applying different rates. And also this code here and this code here, they are also not duplicates. We are assigning that to different numbers. We're not really duplicating anything here. Are there any other places where we got duplicates in this particular design? Anyone can see that? Go ahead. Yeah, exactly. So this one here is kind of interesting to see. The logical structure that we're using for every method is going to discriminate between the two kinds of students, right? So here, what we have is kind equal to 1, repeating kind equal to 1. And also kind equal to 2, also kind equal to 2. Right? We got two duplicates. In this case, we only got two kinds of student. Imagine that if we got 5 kinds of students. That means for every method, you have to repeat that if, else if, else if, else if, else if. That's what you're going to repeat.
Simplify the syntax by doing switch statements.
You may simplify the switch, but you still have to repeat that structure, right? You still have to distinguish between the different value for the kinds.
But isn't the alternative, which is inherent in this case, we will have to...
Yeah, of course, alternative would be, yeah. So of course the alternative would be inheritance. Yes, I agree. But the flow would be, we want to talk about what if we don't have inheritance and try to see what's the problem. And then we move on to inheritance. Yeah. Okay, that's duplicate number 1. And then we have here duplicate number 2. Okay. Go ahead.
So how would you check the kind of this student without violating the first choice?
The single choice principle. How do we do that? Yeah, don't worry. So for this design here, apparently it's really the spirits for the design. So that's why we're criticizing it. For this design here, there's no way to change it because that's how it works. So we're going to see how we do that in a moment. Yeah. So design number 1 here, okay, that's the second drawback. It definitely violates single choice principle. Let's do one more exercise here, okay? That's also important. Whenever you want to think about software design or software development, you want to think about your project may not only last for 2 months, 1 semester or only 2 months. It might last for years, subject to evolutions, right? Let's say at some point we decide for our student management system, we want to have a new kind of students to be introduced. Okay? Let's say kind is equal to 3. And if it's equal to 3, that means we have international students. Let's say. Just different kind, right? Single choice principle tell us if you want to make a change, in this case, I want to introduce a new kind, there should be a minimum number of places you have to change. In this case, how many places do we need to change? Is it a single place or more than one single place? 2 places, right? because in each method, you somehow have to do the discrimination now for kind equals 3, right? So let's now take a look, right? So here, for example, you will have to add right here, you're going to say else if kind equals 3, and then you do something, okay? But that's not the only place. You also have to go to other method as well. Imagine that if you got 10 different methods in the class, you got to go to 10 different places, okay? So you got to go for else if, and then kind equals 3. Oh, I beg your pardon. You shouldn't go there. Let me just fix that, okay? You should go right after that series of if statement, basically right here, okay? You're going to say else if the kinds equals 3, and then you do something, right? So that's definitely some duplication. All right, similarly, if this one, let me hand wave a little bit. What if, let's say, now we want to cancel resident students? In that way, how many places do we need to change? Also 2. That means we don't have to check kind equals 1 anymore. Also, we don't need to check it in this method as well. So there are multiple places you have to change. All right? So this design here, basically that's all we want to say about the first design. You want to, number 1, understand how the kind variable is being used and how we write those if else if structure or switch statement, whatever you like. But you need to have a way to really discriminate between the different kinds values. Once you understand about the implementation, you're going to use the cohesion and single choice principle to judge. And this design here violates both. However, don't get me wrong, this solution here programmatically will still work. You might still pass all the JUnit test cases, but it's just not a good design. Okay?
Can't you do just a simpler design with having, instead of having kind equal just the maximum, and instead of having premium rate and discount rate, you just have rate with the set.
You can make some modification if you want to. Let's just stick to this one here.
So
Yeah.
after this, you don't have statements. You just have the petition is just petition times rate.
Yeah, maybe show your design to me. We can discuss. Okay. Yeah, I'll appreciate that. Thank you. All right. So now for this first design, let's go a little bit. Okay, that's the first design. So the first design violates single choice principle and violates cohesion. Let's now try to look at the second design and see if there's any improvement we're going to make. All right. The second one. So now we are moving something that's gradually looking a little bit similar to what we're going to have ultimately for inheritance, but not just yet. Let's see the second one here. The second one here, we basically have 2 classes. Okay, so we have, let's say, resident students right here, and we have non-resident students right here. Okay, so these 2 student classes have nothing to do with each other. Okay, they're completely independent. Okay. But let's take a look at what the attributes we have. You can see we have right here, we got name. We got courses and courses. We got NOC, we got NOC. That makes sense because that's what they share in common. And also the constructor, we got to initialize the name, initialize the array, and also the same here, and also the same here. And also the register method, let's say for this design here, let's not worry about any this difference between the maximum number of courses you allow for each kind of student. Let's say you just register. And the way you register will be just to add into the array. Let's say they're all also the same. For the get tuition, the way you calculate the base amount are also the same. Okay? The only difference is, this might look a little bit more promising. You can see in the case of the resident students, you got premium rates right here. You don't have discount rate, so that means you can just use the premium rates. And in the case of non-resident students, you actually have discount rate. And then you can use the discount rate right here. Okay. So this programmatically will still work, right? But it's a different design. So rather than having a single class of students, now we have 2 different classes, just resident students and non-resident students. Still no inheritance. So we're going to use the same principle to judge. Okay? What about cohesion? Are we only putting relevant attributes and methods in a single class? It looks like what we had before is problematic. Before we used to put premium rate, discount rate in the same class, but not anymore, right? So you can see over here, point number 1. So we got premium rates and we got discount rate. The fact that we actually put it into 2 different classes, right? So that one there satisfy cohesion. Premium rates and discount rate put in different classes. Okay. But the next question is, so cohesion is good. How about single choice principle? Remember, single choice principle is about duplicates. Do we have duplicates here? Quite a lot, right? Did you see that? Anything I put in blue is actually duplicated, right? You can see in these, well, putting it another way, the only thing these 2 classes are different are just about the premium rate, discount rate, and also this little usage about these 2. Apart from that, it's all duplicated. So lots of duplicates, right? So single choice principle violated very badly. But single choice principle violated. You got lots of duplicates. Okay, lots of them. All right. So the second design, in some way, is a little bit improvement from the first one because you satisfy the cohesion by having 2 separate classes. But single choice principle violated very badly. It would be nice if we can somehow improve this one as well. We'll see. Okay. So let me just say one more thing, 2 minutes, and then we'll take a short break. Okay. Let's see how these 2 classes are going to work very quickly. So let's say we got 2 courses, C1 and C2. We got C1 and C2. Okay. And then we are basically creating 2 objects here. Let's say we got Jin, resident students. So Jin, resident students. And also we got Jeremy, non-resident students. Jeremy, non-resident students. Okay. And then here we're setting the premium rate to be 1.25 and the discount rate to be 0.75. Let's write it down. So this will be 1.25 and this one here will be 0.75. Okay. And for register, it will be very similar. You just basically add the 2 courses into the array, right? Index 0 is going to point to the first course. Index 1 is going to point to here. And similarly, for these 2 register, index 0 point to the first course, index 1 point to the second course, right? Basic. Okay. And then when we try to do get tuition, so when I say gym.get tuition, it's going to calculate the base amount. Let's say the fee. Let's make some assumption. Let's say the fee here is simply, let's say 500 and 500. Maybe 2030 and maybe 2031, let's say, the 2 courses. Okay? So get tuition is actually going to, for gym, it's going to calculate base amount, add up these 2, 1,000, and then multiply 1.25. So it's going to be 1,000 multiply 1.25. The base amount will be the same between the 2 objects. And also we got Jeremy.get tuition. Okay? Oh, sorry. So Jeremy.get tuition here is going to be, again, Jeremy point to these 2 courses. So 500, 500, 1,000, multiply 0.75, right? So the rates is different. 1,000 multiplied by 0.75. The actual value here is not important, but you want to see they are calculated. Some parts are the same, base amount, but some parts are different, depending on which kind of student you are. All right, any question here? All right, so the second design actually satisfied cohesion, but not single choice principle. Okay, so let's take a short break and then we'll take attendance. All right, I want to say a few more things just about the second design. Let's see this. Okay, this one here is like a similar idea. I just want to say very quickly. Let's say we got duplicates, especially we got duplicates right here, register method here. And also we got the register method here. Okay, we got these two. Okay, and then these are complete duplicates. Let's say now we just want to somehow change the policy. Let's say we somehow want to introduce a new constraint about maximum allowance. So that's the new if then else we want to add to say if currently you have already reached the maximum number of courses that's preset, you should really throw some exception, right? So let's say that's what we want to do. In that way, we want to ask about whether the single choice principle will be violated. In this case, apparently yes, because in that way, you want to ask about how many places should we go to change? Well, how many methods? How many methods should be impacted by this particular change? Okay, and in this case, obviously, you have to go here, and also you have to go here. So you got to go to multiple places, right? So that's another way to really see you really violate single choice principle. You got duplicates, so every time you want to change things, you want to modify every occurrence of the duplicates, okay? Every duplicate has to be changed. Has to be changed. Okay. Okay. So it's a violation of single choice principle. Okay. There's another possible change. You can also take a look. I'll leave that to you. Okay. That's also mentioned in the slides, but I can also try to visualize and convince yourself. Right. It's important to see why single choice principle might be violated. Okay. All right. So let me say one more thing. This is also important, and then I will move on to a little bit about inheritance for today. Let's now talk about how we may define the student management system. Before I talk about it, let's see which slide I'm talking about. Okay, so it's now everything has been covered until over here. All right, I'm talking about slide number 11. Okay, so this is a very important slide because this is some very important comparison you will also have to make once we finish the whole inheritance lecture. Slide number 11 tells you this. If you don't have inheritance, you want to create a collection of students, what would you have to do? Because the resident students and non-resident students, they simply have nothing to do with each other. So the most intuitive way is to store multiple arrays into the two different student objects. So what I meant by is something like this. So let me just show you the first part, and then we'll talk about some comparison. So here you can see we got one array here for resident students. I got another array here for non-resident students. So here it really depends on how many kinds of students you have. You need that many arrays to store. Of course, you might be thinking, can I just not declare the type here just to be objects? In that way, I can store anything inside. Programmatically, yes. However, that's another issue. This design is even worse than actually not using inheritance because it's going to subject to lots of casting, okay, in your design. But anyway, that's a little bit off the track. I just want to say, since the individual classes for students have nothing to do with each other, we have to store them in separate arrays. Okay, so here, right here, the number of arrays correspond to the number of kinds of students. Okay? Not a single array. Imagine that if you got 10 kinds of students, you need 10 separate arrays. Each array will need a separate counter to keep track. Okay? That's something you want to watch out for. All right? And then, so we're going to go over also the rest of the detail as well, but I want to show you an important link. So at the end of the slides, so there's a link there to say a polymorphic collection of students. So this is something to contrast, okay? So if you click on that, it's going to bring you all the way to a very late slide, slide number 83, all right? Slide 83 here is about once we introduce about the idea about inheritance. So there's an important concept called polymorphic collection. So once we get there, we will be able to have only a single array of students right here. Only a single one. Doesn't matter how many kinds of students you have. Doesn't matter. It's going to work well without having to do unnecessary any typecasting, etc. So that'll be the ultimate design we want to arrive. So that when you study for the exam, you want to really compare slide 11 and slide 83 to see why these two are different. Okay, but let's go back to 11 just for today. Okay, so if I go back there, let's say collection without the inheritance. Okay, let's see a little bit more. So we got separate counters and also we got separate mutators, adding resident students or adding non-resident students. Now, let's say we have a register method that's going to register maybe a common course for all the students, resident or non-resident. Let's say 2030, every student has to take it. So in this case, right here. So this is the method we are trying to define. Think about how it's going to work at the runtime. At the runtime, we got resident students right here. We got non-resident students right here. We got two separate arrays. In order to iterate through each one of them, let's say maybe one array has 10 students, another array only have maybe 7 students. You got to go over them separately. Okay? So think about this for loop here. The first for loop is actually going over this particular array. And the second for loop over here is actually going over this second array, because you can see right here, this is about resident students array, and that one is about non-resident students array, right? You got to go over them one by one using different upper bound, like a different counter. You can see the counter here and the counter here are different, right? So if you got 10 kinds of students, you got 10 different arrays, you need 10 different loops in the register all method. Okay. Question here? So all these are just a consequence of this particular design that we ought to know. Okay. Okay, if you're okay with this, let's now move on to, we are very much ahead of section B. So I would suggest we do maybe a little bit more than yesterday, but we can do some recap maybe on Wednesday. Let's now talk about what if we try to arrive at a solution that's going to use inheritance. Okay, we're going to introduce different keywords. Okay, let's see. Right here. So this will be the ultimate solution, which you have to code for lab number 4. Okay. Let's now analyze this, these 3 classes here. So this is like a design number 3. Okay. And here, design number 3 is going to be the ultimate one that's going to satisfy. I'm going to tell you first, but we're going to justify. We're going to satisfy cohesion. We're also going to satisfy the single choice principle. But let's see exactly how. Let's start with the syntax. Here, you can see we have a single class called students right here. Okay, students. And then we got 2 classes over there. And then they are really using a new keyword that we are going to learn. So here, you can see resident students extends students right here. You can see here we got non-resident students extends students. Okay, that's the first keyword you want to learn for inheritance. Okay, the extends. Extends right here. Okay, let's now first of all understand this syntax over here. Whenever you say extends in Java, you want to pay attention to what appears on the left and what appears on the right. So when you say extends, so something on the left and something on the right. Okay, in this case, you can see we got resident students and non-resident students. These 2 are on the left. So you got resident students and also non-resident students. So these are the 2 classes on the left. And on the right, we only got students and students. Okay. On the right is something we call a parent or superclass. Parent or superclass. On the left is what we call a child or subclass. You can use these 2 terms interchangeably. So you can either say students is a parent class of resident students, or you can say student is a superclass of resident students. You can say either way. Okay. So that means here, for students here is the common super or parents class. Because both of these two classes extends this particular class. Diagrammatically, usually for inheritance, we simply say this extends this, and this extends this. You see the arrow direction. Okay? So the arrow will go from the child into the parents, and the child into the parents, not the other way around. Okay? You gotta watch out the direction for the classes. And what is so important about this parent class? In the parent class, all the non-private attributes and methods are inherited to the child or subclasses. I'll talk more about what I really meant by non-private. So in Java, you actually got different choice of the modifier. You can say maybe an attribute can be simply no modifier. It can be a private one. It can be a protected one. It can also be a public one. So there are certain distinctions we have to make. I'll talk about it maybe on Thursday, okay, just to talk about it. But for now, let's assume we don't have any modifier, okay? So that means over here, the name, registered courses, number of courses, these will all be available and inherited to these two classes. All right, so let me just make that notion. So think about this. Okay, let me highlight. Anything I highlight in green will be inherited to both subclasses. So that means in those subclasses, we don't have to define or declare those attributes or methods anymore. Okay? So the name over here, the array, and also the integer counter. Okay? And also the entire register method as well. And this one here. You can think about the get tuition method also entirely. So all these, everything I put in green, they will be inherited verbatim. All of them, they'll be inherited. Okay? So this is why you can see that in the resident student class, we don't really have to declare name, register courses, or register method. We don't have to. Okay? They're inherited. So no duplicates. So the fact that we actually got code inherited from parents to child, that's really the way for inheritance to solve single choice principle violation problem. Okay? So that's also important to note. So this is really, so since they are all inherited, in that way we minimize duplicates. Minimized duplicates. So in that way, we will satisfy single choice principle. We'll see a little bit more deeply a little bit later. Okay, let's go a little bit more. But now let's take a look at the, let's say, just registered students class only. Okay, what do we have? You can see registered student here is going to inherit everything I highlight in green, right, from the student class. But you can also add something new to this class in the child class. I'm adding premium rates only. This is applicable to resident students. Similarly, for non-resident students, I'm adding discount rate. I'm adding some child-specific attributes. Okay? So let me now also write it down as well. Think about this one here, premium rates. And this one here is about discount rate. So these two are child-specific. So these two. So these are child or subclass specific attributes. Well, we can also derive from there, since we are able to actually add just what's necessary for that particular class. That's how we satisfy cohesion. So that means cohesion is satisfied. You don't really have to mix those two. Okay? So far we talk about everything in the parent class will be inherited by default to the subclasses. That's how we minimize duplicates, satisfying single choice principle. And for each subclass, you can add as many child class specific attributes or methods in that particular class. In this case, we just see premium rates and also discount rate. But there will be some method example as well, but attribute is good for now. Okay? What about the get tuition method? You can see get tuition here and get tuition here. All right? This one, we're going to talk about something called overriding, which we did talk about in the equals method. So what we look at is, let's look at get tuition. Get tuition here. Think about, this is the parent version. That's going to be inherited by default. And then we also have another one here, get tuition. Right? You can think about this is the resident students overridden version. And this one here, get tuition here, that's overridden again, but independently. So this is a non-resident students overridden version. Okay, let's dive deeper. Okay, remember we spoke about before. Okay, let's take a quick look. In the design number 2, they get tuition for resident students and they get tuition for non-resident students. As you can see, this part right here and this part right here, they are completely identical. They're duplicated. But now we have already factored out this particular base amount calculation into the parent method, get tuition. And all that we need to do is to make sure we have a way to call the parent version of the base amount calculation, reuse it, and apply that to either a premium rate or discount rate. I'll show you exactly. Okay? Let's say here. First of all, let's now highlight just this part here. The body of the parent version right here. So this is the base amount calculation, which we want to reuse, but we don't want to repeat. Okay? We don't want to repeat the code in the in the subclasses because that will violate single choice principle. The way we do it is by using a keyword called super. Okay? So the super keyword, one way to use it is like this. You can see the super here and also super here. You can think about super here as opposed to this. That might be the easier way to think about. So whenever you think about this, it's more like a current class or context objects. So if you see anything like this within this class over here, you're really referring to just resident students or the context objects, right? However, when you refer to super, you're really following this extends arrow and go to here, all right? So the super over here is really about the parent class. Okay? In this case, it will be the student class. You can think about the student here is super relative to, is the super relative to resident students and non-resident students. Okay? And let's see a little bit more closely how we are using it. You're using super like almost like a context objects. So when you say super.getTuition, what does that mean? That means here, go to my parent class and call this method first, call this version, which is going to return the base amount, which is going to store in base. Similarly, here I say also go to my superclass, which is right here, and then go to that version, call getTuition, and save that into the base amount. Okay? So these two lines are really calling the same method. So this one here, and also this one here, both of them are really calling the super version. Okay, so these two. Think about these two. They are just reusing the parent version of the method. But more to it, you want to make sure in the resident student class, you're going to apply the premium rate to the base amount. And in the non-resident student class, you will apply the discount rate. So here you can see we got premium rate right here. And then here we got discount rate. They're going to be applied differently. Okay? It's really simple 3 pieces of code, but actually it says lots about inheritance right here. Okay? One more thing, and then I can see if you got any questions. The constructor here, we can also use the super keyword, right? You can see resident students constructor and also non-resident student constructor. Both of them already got inherited all the attributes right here, but we want to initialize them. But we don't really have to repeat these 2 lines of code. We don't have to. So you can think about here, we say super. So the way you call the super version of the constructor versus the super version of the method, the syntax is a little bit different. When I want to call the super version of the get tuition, I got to say dot and also dot right here. But if I just want to call the super version of the constructor, I just use the super as if I'm referring to the students, just calling that constructor. Okay, over here. So think about the super over here is really like a students. And the super over here is also like students. And these two are just calling this block of code, really, okay? So think about here and here. They're calling this block of code. So we are reusing. It's just like calling a helper method, but just using different syntax. So we have seen actually all the syntax you're supposed to know at this point about implementing inheritance. So you're definitely ready to do lab number 4, right? So you want to know about how to use extends to really build your parent-child classes relationship. Also, you have to know how to use a super keyword to really call the super version of the method. Okay? All right. Let's now do a little bit more summary, and I think that'll be it. Okay? It is important to just understand the big picture about when you actually program in inheritance. So what exactly do we do? Okay? So when programming with inheritance, just OOP in general. So definitely Java will apply, but other languages will apply as well. Okay? So think about you have some parent class, for example. Okay? I'll just say parent class P. Right? It's a parent class. Underneath it, you can have as many child classes as you like by using the extend keyword. So you may have right here. So let's say you got C1, and also you got C2, and you got as many child classes as you like. So here I'm just simplifying the story a little bit. So in reality, you don't really just have 2 layers, like a 1 and second. You may have multi-layer of the inheritance. That's something we'll get into. But for now, let's make it a little bit simple. So you got 1 single parent, you can have as many child classes as you like. What's the general design principle? In the parent class, since everything you declare here that's not private will be inherited to all the child classes, you want to think about what's really all the child should share in common. So you want to avoid or minimize duplicate as much as you can. You put all the common part in the parents. So number 1, you want to declare attributes and methods that are common to all the subclasses. Okay, so this will satisfy single choice principle. Okay, you want to minimize duplicates. And then you also have each individual child class. Okay, right here. So each individual child class, you can declare any child-specific attributes or methods. You can declare additional attributes or methods applicable to this subclass only. For example, in the resident student subclass, you declare premium rates. In the non-resident student class, you declare discount rate. Okay? I should really say this is 2A, also 2B. How about overriding? If there's a particular method that's inherited from my parents, I somehow want to redefine that a little bit, or maybe reuse part of it and use my own definition, like a get tuition. In that way, I can also do it in the subclass. So here I can also override or redefine the inherited methods. Okay? So in the parent class, you do number one. In the child class, typically you do either 2A or 2B. So that's more like a design principle. For each child class, you can either try to define some new stuff. Typically, you will have to add some new stuff to your child classes. And also, you can override certain things that's inherited from the parents. Questions? All right, that's good. So I'll stop here, and then we'll continue this from Thursday.